layout. You're going to hear from Lee in a little bit on piles and shafts. You'll hear from the other engineers as well on different aspects of structure inspection. Layout's really critical. If you don't get this right, it don't matter if everything else goes right. If this goes wrong, it's a good chance the whole thing may have to come down to go back up. Anybody got a copy of this? Anybody seen this before? Manual for structure layout. I didn't bring my whole version. The 2001 version is still out there and it's still pertinent. It's got a different cover on it. You may have seen it, it's bound. I haven't seen a bound version of this one, but it is available online. This link here, you can type that into a web browser and it'll shoot you right to it, save it on your iBooks. It's a good reference to have. The only thing different from the 2001 version is the chapter number. Also, if you go to the NCDOT site, type in manual construction layout, it'll pop right up. And you can download the PDF and save it. Guidelines. This is straight from the manual. All major structures will be staked with reference lines which contain at least 3 reference hubs on each side with tacks. These hubs should be spaced equally apart at adequate intervals. Reference hubs should be checked for accuracy after sitting all winter. If you got 2 structures side by side, the reference hubs for each bridge should be color coordinated. You want to put these hubs out as the manual calls for. You're supposed to have 3 hubs. I'll show you a diagram in just a second. At each end bent on each side, bent, indent at the other end, or if you got more vents in the middle. The reason you want these extra hubs is they get knocked out, they get kicked along the way, sometimes get removed. So you need these additional hubs to make sure that you got reference points when the surveyors come out. If they don't have them, kind of got to start all over. You're out running a level or a total station. The contractor, depending on what he's running, if he doesn't have something to come off of, or if they get damaged, you don't know they're right. You need something to check into, so you need the more points, the better. You got sister bridges. Anybody on a project right now that's got sister bridges, where they're twin bridges side by side. You want to make sure those stakes are color coordinated somehow. Either the stakes got different colors, the writing on the stake, or put different color ribbon around them, preferably all 3. Because we've seen, I'll go over some issues we've had with sister bridges before here in a little bit, but you want to make sure that those stakes can be differentiated by the surveyors or by the contractor if he's running his own levels. You don't want them using the wrong stakes because that can cause you headaches. And if they're side by side, there's a good chance they're going to overlap. Depending on the skew of the bridges or the indents, if they're at 90s, there's a real good chance they could overlap. Bridge stakeout, this is pretty much from the manual as well. Contain 2 reference lines for each indent, interior bent, and a long chord line. I'll show you those figures in just a second. This is straight from the manual. It says set a minimum of 2 temporary benchmarks to remain in place throughout the entire bridge construction. This line here, 1 benchmark is to be used for substructure and 1 for superstructure. Don't really want you doing that. This is what we'd rather you do. Try to use the same benchmark throughout the whole bridge. I know some of you's got real long bridges in here. It's tough to use 1 benchmark the whole way through because just of the length of the bridge. But if at all possible, try to use 1. You'll need a second one to check into. It's kind of a backup benchmark. But try to use the same one all the way through construction. Got an example in a minute. I'll go over some errors where we had issues where they switched benchmarks between. Here's your typical layout. This is diagram from the manual. See your bridge center line, survey reference line. You see your hubs here on each side. At each bend, each end bend. That's kind of how it should look in the field. You see your stakes laid out along those lines. Or are y'all seeing this on the structures you're on, laid out like this? And if you're not, is there a reason? I mean, there'll be instances where, depending on the skew of your bridge, if the creek's running, you may not be able to put them in. If you're in a wetland area, it may be difficult to get them in. But if at all possible, you want to try to get all these stakes in and the points So you got reference lines and reference points. You're going to turn your angles from the bridge center line to the bent lines, measure record distances from the center line of the bridge to reference points. I'll get into this in a minute, but the bridges should not be laid out using radial stakeout. It's got a line in there about the resident engineer approving it, but I'll go over that some in a minute. Here's a similar diagram. This is for a curve layout. Everything's pretty similar, except you got your long chord line here. See your 3 hubs on each side of the work point. So that's the way you want it to look. It's got the same notes in there about turning the angles. Anybody on a culvert right now? A couple? Okay. Here's your stakeout for a culvert. Instead of 3 points kind of in the middle, you got 3 at each end, on each side at the ends. You got 3 off the ends of the center line. Here you got every 50 feet or less, you should have a stake showing you the cut field to the top or bottom of that slab, depending on how they stake it. So should have layout looking like that. Anybody on a culvert not seeing this? Okay. I'll put this in there. You'll see this in some plans. This is from a job in Guilford County. This is your survey control sheet. Just put it in here mainly for reference. I got a diagram in a minute showing, but this kind of shows you where the disc you put out, that's location and surveys come out ahead of the project. They'll have those marked. It's kind of blurry the way I had to zoom it in, but I just wanted to mainly show you kind of what the sheet. This will actually be in your roadway plans. It's usually about the 3rd or 4th sheet, somewhere in there, but it'll be in there. It'll kind of show you where their points are, and it'll tell you where the benchmarks are at that they used and set up. Sometimes you may be able to use those for structure. You check them, check the elevation on them. If they're close enough to the bridge, you may be able to use them. This is the area I'm focusing in on down here. It shows you baseline data, it gives you that data. There's your benchmarks. Here's their points that they use. Gives you northing and easting and elevations. Most of the time, survey parties, one's going to be using that. Go ahead.
The tree that you benchmarked on, you cut down.
Okay, well, locations, not locations, but your survey party, I didn't ask this before. How many people in here are working out of an office that does not have a survey party? Anybody? Y'all don't have one?
Yes.
Okay. Right, but Brian's office does have a survey. So you got somebody to come behind you and check it. There's offices, a couple offices across the state that does not have a survey party. They're either using locations or district or somebody is who they're using right now to go back and check. But your survey party, even if you got contract surveying and you need them to come check something, one of them is going to set a benchmark. If the one you're talking about is gone, they might not even use the one location sent, but they just put it in there in case you want to use it. They may set their own benchmark in a location that's closer to the job or easier to access during construction. But they put this information in the plans just so you have it if the surveyors want to use it. But at the pre-con, it's a good time to bring that up with your surveyor. Sometimes I've been to pre-cons, the contract surveyors don't come, but that's a good time to run through this with them. All right, this is the same job I just showed you the survey control sheet from. This is what you want to see when you come out to a job. This is the indent right here. There's your first reference point. There's your second one. You can see the ribbon for the third one out in the woods there in between the trees. They were able to get them all in here. The indent was far enough and the creek was on pretty much of a parallel with the indent, so they were able to get all the points in. This is the other side of the bridge. Same bridge, other indent. I'm looking in towards the indent this time. This is the outermost, the third stake. This is the second one. Guess where the first one's at?
Oh.
Yeah, it's been knocked down. It's on the other side of that silt fence. I should have taken a picture of it. I saw it laying there, but That's why it's critical to put these extra reference points in. Keep your line, got extra reference points for the surveyor. Because if they just come in and put the 1 point in, and they got nothing to reference when they come back out in that vicinity.
I want to say one thing here, for all your over hats in here, surveyors. If you sit on this point and backs like this and shoot a far front sight, is that a good practice? It's not. So when you lay these out, make sure you're getting a distance. If you gotta shoot a long front sight, that you're getting a distance equal or greater on the back side. It's just surveying practices that we're getting away from. So just noticing that picture there. Even though it's showing what we're wanting, it's still not demonstrating good surveying practices that we're getting away from. So, anyway.
I will say, the survey party from the office did this one. Lots of times what I've been seeing with contract surveying, when they're not putting out this many reference points. I want to try to get them back in the habit of doing that. Time to bring that up to the pre-construction conference. Bring up, basically go back through the manual if you need to. It's not very many pages. Let them know what you're looking for. Especially on these smaller bridge jobs where it's really simple to do if they'll just do it initially. It may take them an extra 30 minutes to do the whole project and set these points up ahead of time, but they need to do it. They may buck you on it and not want to do it, but assistant residents, talk to them about it. Try to get them in the practice of setting these points up so you got them out there. Radial stakeout. By the manual, can we stake a bridge using radial stakeout? The answer is no. There's a line in there that says, with approval from the resident engineer. We don't want them using radial stakeout for the bridges. The reason why is it utilizes a series of open shots. There's no tie-in like there is with traditional traverse surveying. So there's no way to determine if they're unresolved errors, namely if they got a mistake. You got to do all these additional independent measurements to tie it back in and isolate the errors. And if they're going to do this, we want them just to do the traditional traverse survey. It's easier, it's more accurate. GPS. GPS be used to stake out bridges? The answer is no. Big no. Why is that? Yeah, vertical accuracy, that's exactly right. I've been told horror stories, contract surveyors coming out trying to use GPS every time they come out, and they're seeing, they may get 5, 10, 15-foot difference in error each time they come out, trying to check in and set up. So definitely don't want them to use it. Need to be using a total station, something coming off a known point. Don't let them use GPS. If you see them doing that, tell them no. Don't let them get started on it, because it can cause you errors and a lot of headaches in a hurry. Contract surveying does not change the way bridge stakeouts are performed. I know we're preaching this, and I'm preaching this, but what we're seeing is that there are some differences in what we get with our survey parties. They're trying to do things faster, speed things up. They're not laying out as many points, setting it up like the manual calls for. So, but they're still supposed to. They're still supposed to do it according to the spec book, according to that manual. So we need to try to get back to that if they're not doing it. You're seeing it or not. Like I said, they should be following the stakeout manual, performing it as it recommends. Most importantly, when you get the initial layout, have your surveyors, your survey party come out and check it. When they give you build-up numbers, make sure you check them. Make sure your assistant checks them. Get the survey party to check them too. The more checks you got on their numbers, the better off we are, the less likely we're going to be to have errors. So check it as many times as you can. Make sure they're giving you that information as well. If they're not wanting to provide it, talk to your assistant, talk to your resident. Make sure they're giving you their numbers. We need to have those checked for sure. Can't iterate that enough. Make sure you check their numbers. So what are your responsibilities to ensure an accurate stakeout? For projects with contract surveying, they're gonna come out and perform this initial stakeout. When they do that, you know, who knows? The best time is to come out right before the contractor mobilizes and gets started, so everything's out, it's fresh, it's new. Reality is, they're gonna come out there as soon as the contractor tells them to. Usually, it may be a week before they get started, a couple weeks. What we want them to do is come in right before the contractor, but sometimes they'll come in right after the availability date, they'll lay out everything and they're gone. Okay, until the contractor says he needs them again. Well, the contractor may not show up for 2-3 weeks after the job starts. How long is too long to leave your stake out there unattended, unchecked? Week, 2 weeks, that's probably the most you want to leave it. You probably want to get your survey party out there to check it right before they're going to get started construction. You want to make sure that check's done, doesn't delay the contractor from getting started. So make sure you let the survey party know when the contract surveyor is going to come so they can come check it. If the RE office, how many, you got projects right now, the RE office is doing your survey? Anybody got one, couple? Okay. You, the inspector, need to let them know as early as you can when they're going to be needed. Contractor's not always going to tell you. He may tell you at 4:30, hey, I need somebody out here tomorrow at 7:30. That's not going to be enough time, lots of times, to give your survey party time enough to load all their data in, get their numbers ready to bring out. So try to give them as much notice as you can. Those of you that have been doing bridges for a while, you're kind of going to know the stages. You're going to know when the survey party needs to come check something. So you can kind of give them a heads up so they can get their stuff ready. Those of you that haven't been on bridges before, try to fish it out of the contractor. Talk to them, ask them when they're going to be needing stuff. Keep that communication open. And the more bridges you build, you'll recognize when things are going to be needed. Anybody in here run a transit or level? Several? Okay, that's good. Good skill to have. There'll be times in the project where you can check things. You can check the line of the drilled shafts. You can check your pile alignment. You can check the cutoff lengths, elevations. You can check your bridge seats. You know how to run a level. So there's things you can do to help the survey party out where they don't have to come out as frequently. That's good. If you're not comfortable, you have one, but you're not comfortable, don't try to run it. Let the survey party come out and do it for you till you get more familiar with it, more comfortable. We don't want you trying to run it if you're not comfortable or not sure about things. Most importantly, make sure you double check those calculations they send you. Make sure that layout's checked at every stage of construction. Just so we're checking to make sure if anything's been damaged. You don't want to keep carrying an error throughout. Had a bridge recently where we think something got damaged with the bent stakes while they were moving dirt. Didn't catch it till we started setting girders. Fortunately, they still fit in the slots, but we're about an inch off where we needed to be. We realized we had a bend there, and we're able to correct it and not have to do any corrective action. But if the error would have been caught sooner, or if it had been worse than it was, we could have had some major problems. But the staking wasn't checked when they went to build the bent, so they carried it all the way to the top. We don't know at what point, the stakes got off, but we were about an inch and a quarter off. So you ask, what can go wrong? This is kind of far-fetched, I found on the internet, but I thought it was kind of fitting. Let's hope this never happens. I don't know many contractors are going to build a bridge like this anyway, but there's possibilities that things can go wrong. Some of the errors we've seen, had a benchmark transferred incorrectly. Contractor, getting back to what I was saying earlier about the two benchmarks. One benchmark should be used primarily for reference. You check into the other one. They actually switched their benchmark from one end bend to the other. And the bridge was short enough where they should have been able to use one, but they transferred it to another one. They evidently transferred it a foot too high because that's the way the end bend was built. So, guess what happened? Tear it out, start over. So, at some point though, before they pour that invent, somebody needs to be checking the bridge seats. So if you can run a level, check it, or make sure the survey party can come out and check it. When we get to the point where we pour it that way and it's built, then we should have done better. Yes, the contractor built it wrong, but if we're doing what we're supposed to be doing, it should have never got that far. He might have had to tear down his forms, dig down some more, start over again, cut some piles off or something to get the elevation right, but that's minimal compared to all that concrete he had to eat at the demo, the time he took the demo, that invent. We had a structure shot in, corners were shot in the correct locations. Fortunately, they were close enough, the contractor built the bridge proportionate all the way up, but we got to the top, started noticing some things in the superstructure wasn't matching up, couldn't figure out why. Well, I went to check, the corners of the bridge weren't exactly in the right place. Again, structures management kind of saved the day with us on this one, gave us some options we could do, didn't have to tear down anything. So fortunately, but you know, just because they go out and shoot things in, if that layout would have been checked, it's something we could have caught. Had an incorrect skew angle that was used for one of the invents. This happened on Sister Bridge. This is what I was referring to earlier. Had two bridges side by side. Not sure if the contractor read the wrong plans, or he read the wrong stake, but he shot the skew angle for the sister invent in for the wrong one. Built the cap and everything. In this case, inspector tried to get him to pull a tape to check the anchor bolts, make sure they were correct distance. He wouldn't do it. Went ahead and built the invent. So we get out there, I go out there when they're setting girders. This has happened when I was an assistant. First girder sets, dead set, good. Second one was a little deeper in the slots. Something wasn't right, we didn't think, but we kept going. When we got the third one, we were about this far short. So, that's all it took. He had to wind up tearing it out, because there wasn't nothing we could do at that point to correct it. But if he would have took the time to let us check it like we're supposed to, had his surveyors come out and check it, then we wouldn't have never got to that point. So, but as an inspector, do the best you can to try to get them to check stuff. There's going to be times you get stubborn contractors. He's not going to want to pause to let you check stuff, but you need to try to get him to let you check it. If you're going on the level, if you're not, give him time to get the survey party out there. Try to mitigate that, be talking to them, communicate with them, tell them, you know, you need to check that before you keep going.
I'm looking, I travel a lot in different states for, and about all the states I've been to, the contractor has to give you access to inspect it anytime, period.
Right.
Not whether they, well, we're gonna hurt them, you can stop and let me do it.
Yeah, okay. Well, that's the way it should be done with us. But we all know we've been around contractors. Sometimes the survey party, depending on what they're doing, may not be able to come out right away. But we need to be trying to check stuff before they go on to the next stage of construction. Checking your seats, checking various things before you keep coming up with the structure. All right, we'll get into the FEMA regulated stuff for bridges. This is kind of a checklist at the end of the project for your as-builts. Anybody in here doing as-builts for their project? All right, this is kind of your checklist for that. I threw this in here after we got some comments from some of the other training areas we've done. But it kind of gives you a checklist on what we want. This is for bridges. Got it for culverts, stuff you need to be verifying. Reason we want to do this, FEMA is going behind us. We have to turn in plans with all these elevations on it and dimensions, and they want to know that we built the structure like it's supposed to be built. Correct elevation, correct links, correct hydraulic openings for the culverts and the bridges. You may think, you know, you go out and build a bridge, the old bridge, you know, if you're looking at kind of a plan, well, not a plan view, but a cross section, or, you know, the view that shows the hydraulic opening.
Profile?
Yes, correct. Brake part. Your opening may be this wide. Well, the new bridge, it may be this wide. So the contractor comes to you and says, well, hey, I don't want to excavate all this dirt. He may not have bid it to where he can make any money on it. Okay? So do we want to leave that dirt there if it shows it taking it out? The answer is no. You want to build it just like the plans call for, because it can cause flood issues. We could go back and have to buy additional right-of-way. We've had instances, one of the other BCZs have told me, well, we've had to physically get an excavator, lower it in with a crane, and dig out what we needed to dig out because the contractor didn't do it right the first time. And they had to do it, basically using a small excavator, dipping it in a big excavator just to get all the dirt out. And the reason, FEMA wants this, they want, the water to flow like it's supposed to. If there's a flood, they want it to flood like they think it's going to flood. And if we cause that to change because we didn't build something correctly, we didn't build a culvert to the correct elevation, we didn't make the hydraulic opening as wide as we're supposed to be. So this is stuff, you need to check, make sure everything's built to the dimensions, make sure we're doing the excavation we need to, and everything's at the correct elevation that it's supposed to be in the plans. All right, your check items as an inspector, your initial layout. As I was going over earlier, make sure the contractor, when the contract surveyors come out, make sure you notify your survey party. Make sure they go out and check the initial layout. Make sure everything's correct before the contractor starts building. Do not let them start building if that survey has not been verified. Like I said, all y'all said you had survey party in the RE office. Make sure they come out at some point, check that before you start building. We want to make sure that stakeout's correct before we get started. That's the best time to make sure errors are avoided. Your benchmarks, you need to do an independent check of them. They should be checking into them each time they come out survey to make sure those elevations haven't changed. Sometimes, depending on where you put them, if you look in the construction manual, they'll have a note in there about not putting them in fill sections because you'll have settlement. They need to be putting them in some kind of hardwood if possible. I know some projects you go to don't have hardwoods available sometimes, but sometimes if they put them on a power pole, those power poles will settle sometimes if you have a lengthy project. So make sure they're checking those each time they come out. Make sure they do the initial check. If they're going to use location and surveys numbers, make sure they verify. Your alignments, your footings, your columns, your caps, be checking these as you go, making sure they're correct. Don't wait till we get up to the cap and realize that the footing, the drill shaft was off 3 or 4 inches. Lee will show you some pictures here in a little bit where we got off some. And just because it fits in the cap, that don't mean it's like it's supposed to be. We still have issues with the structure years down the road. And yes, we can do corrective things sometimes to compensate for it, but we need to make sure that these alignments are right before we come up with it. Keep going up to the superstructure. Anybody on the railroad bridge right now? Nobody? That's
Back and forth.
say what?
Back and forth.
Oh, okay. All right. Well, that's not a bad thing if you're not on one. Anyway, for railroad bridges, check the rail elevations and check the bottom of your girders once they're set to make sure that clearance is right. We don't want to pour the deck and keep going with the structure if the clearance isn't right, because the railroad's going to check us. And if we got a clearance ain't what it's supposed to be, we're going to have to make some changes. And we want to make sure that that clearance is right when those girders are set. So remember to do that. Go ahead.
On the railroad bridges, particularly the ones that wide lines over railroad, make sure you verify that rail height before we start the bridge. Sometimes the rail comes in and changes the rail height after we've done our preliminary location and surveys. So we come in there and build our bridge, we do not meet the 17-foot clearance between the bottom of our girder and the top of the rail, and that has caused some issues. So please verify that rail height before we start even constructing the bridge, because if it's higher than what the plans say, you need to talk to your BCE immediately.
Yeah, like what he's saying, there's a lot of these rail projects going on where they're relaying the lines. It could just be they've done maintenance too, but it causes that rail elevation. If they come back and relay the ballast or something, it may be 2, 3, 4 inches difference, but that may be all you need. If they raised it up, you may not have any clearance anymore. Roadway, it's also a good time to check it for roadway too. If you got asphalt underneath it or a concrete roadway underneath it, it's a good time to check it then to make sure we're gonna have the clearance we're supposed to have in the plans. Because we need to make sure, you know, that we've got the clearance that we're supposed to have. So we don't have to post any low clearance or anything like that for tractor trailers, any kind of oversized vehicles. Your bridge seal elevation, I mentioned this earlier. Make sure that these are checked before you pour the caps. It's a good time to check them then. Make sure your distances between your ankle bolts are right. Make sure, you know, those elevations are correct so the girders are going to sit at the elevation they're supposed to. Time to check them before they pour. So make sure you check them. If you find something wrong, it's a lot easier to tear out forms and replace them at that time than it is once you pour the concrete and find out that there's an error. Your build-ups, need to be doing an independent check of those. Contractor's going to give you his numbers, but you should be shooting your own 10 points, going through, calculating the build-ups to make sure your numbers match. Don't just take his numbers for granted. His elevations may not be right when they go out and shoot the 10 points. So our survey party, if at all possible, needs to come out, shoot their own elevations, and you run your own build-ups. You check them, make sure they match the contractors before you continue on with building that deck. I know there's instances where survey party may not be available, but make sure you run your own calculations. Don't just trust his. Even if you can't get separate elevations, make sure you take his elevations and run your own numbers. Make sure they're correct. Make sure they match. Get your assistant to run them. Get your survey party to run them too. Want to make sure they're right before we continue on building that deck. Your approach slab grades. So the last thing I want to talk about. You're going to get a set of grades in your structure plans. You try to lay it out according to that. Don't let that go at just that, laying it out with those elevations. You built the bridge, you got the best riding bridge you could have. You don't want that approach slab to have a dip or a bump in it. So make sure you pull a string line far enough back on the bridge and off the approach slab to make sure it's going to ride good. Don't take those elevations for granted. And don't try to go by the roadway elevations to tie in. Make sure that approach slab is right. The roadway is a lot easier to adjust than the bridge is. So make sure you pull that string. I still got one today that I ride over frequently that I got a dip in. Bugs me to death. But you know, if we took the time and pulled the string on it, could have took that out, been poured correctly, and would have rode a lot better. Anybody got any questions on structure layout? General questions, specific?